Hello, everyone. Let's talk about the law of sines, and specifically, we're going to talk about sort of a special case. You might remember that in geometry class, we have this angle side side. Okay. We don't talk about angle side side because it has some ambiguity to it. And you're going to see that in these problems, it's possible we can draw two triangles that satisfy the requirements. And so it's important that we know how to say, like, hey, is this possible to draw two triangles? There's only one triangle. Is this even possible to draw a triangle? So let me kind of show you how this works. We're always going to label side A across from angle A, and we'll use lowercase a for the side and capital A for the angle. I'm going to try and draw these, and I'm going to try and draw the ambiguous cases as well. It is tough to visualize sometimes, though, so you'll see how I can sketch them, but it's like, it's not perfect. So the first thing says we're going to determine if we can do one triangle, two triangles, or no triangles given the information that we have. So we're going to sketch what we know, and then we'll see kind of how the math plays out. I'm going to draw angle A with 58 degrees. So we'll say I'm drawing a triangle that looks something like this. Angle A is 58 degrees. Little a is 25. We'll call it A, B, C. We'll just draw them all the same way, and little b will be 22. Okay, so we're going to try and see what happens here, and we're going to use the law of sines. So let's find angle B. To find angle B, I know I have an angle side pair, so I can say the sine of 58 degrees over 25 is, if I want to find angle B, the sine of angle B over the length 22. Now this is a little bit fancier because we're trying to find the angle, not the side length, which means we're going to need to do some right triangle trig. We're going to need to use inverse sine. I want to get the sine of B by itself, so I will multiply both sides by the sine, and now I will have the sine of B, or by 22 rather, and I'll have the sine of B equals this big mess. So we got this whole thing that I have to now calculate, and I'm going to use my calculator to do that. So let's bring the calculator up. I'm going to say 22 sine of 58 divided by 25, and we get 0.746. So what we know is the sine of B is 0.746. Now, if you think about on the unit circle, kind of what we're talking about here, the sine of B is positive 0.7. Remember, sine is the y value. So what we've got here is this y value is 0.746 right here and right here. And what we're going to do is take the inverse sine, and we're going to find out what the reference angle is. So it'll tell us the reference angle if we do the inverse sine. So let's take the inverse sine of that. Inverse sine, that's inverse cosine. Inverse sine of this, 48.27. Let's just make that 48.3, and we'll make it nice and pretty. So we're going to say that angle B is 48.3 degrees. And what you have to realize is that what we found is the reference angle. This angle is 48.3 degrees, or that angle is 48.3 degrees. But what we're going to do now is we're going to see, like, is it possible that maybe instead of the 48.3 degrees, we were actually talking about this angle, which is the one that is supplementary to 48.3 degrees? And the way that you determine that is you just see if it's possible. So I'm going to take 180 minus 48.3. 180 minus 48.3 and get 131.7. So this is the weird thing. 131.7 is it possible that I could draw this triangle where instead of angle B being 48.3 degrees, which is what I think it is it possible that I could draw it with 131 degrees right there? And the answer is no, because if you add 131 to the 58 that we already have, you get something that's bigger than 180, which means this is the only answer. This is the only way you can draw it. You can't draw it another way, but the way you check is you find this angle's supplement and see if it would fit in the triangle. So since we can't draw it, it's tough to visualize because it's impossible to visualize, but when we get one we can, I'll draw both of them and kind of show you what I mean. Let's try another one. This one says angle A is 20, little a is also 20, but the length, so let's draw it. It's going to look something like this. Angle A is 20, so we'll draw it like this. A, B, This is C. Just like we did the other ones, we're always going to try and draw them the same way. A is 20 degrees, and what else? Little a is 20 units, and little b is 32 units. We're going to find the sine of b. So we use law of sines. The sine of 20 over 20, so there's our angle side pair, equals the sine of b over 32. I'll do the same thing to get the sine of b by itself. I will multiply both sides by 32. And now I'm going to use the old calculator to just type it in. So I'll say 32 times the sine of 20 divided by 20. So the sine of b is 0.547. The sine of b is 0.547. And I'm going to try and sketch out to help me kind of visualize again. The sine of b is 0.547. So you imagine there's two different ways you could do that. If you know the sine is the y value, this height is 0.547, and I want to know what's this angle. So to do that, I will use inverse sine, and I will get that b, angle b, is 33.2 degrees. B is 33.2 degrees. So this is 33.2. But again, it's possible that we're actually talking about this angle or this angle. It could be either one. And the way we would find this angle is if this is 33.2, we would find the supplement. So I'm also going to just, while I'm at it, go 180 minus 33.2 and get 146.8. Okay, 146.8. What do you mean 146.8? So if angle B is 33.2, this would be what the triangle looks like, and that's great. Is it possible that this is actually the angle? So instead of angle being 146, or instead of being 33, is it possible that I could draw that as being 146.8? Because that'd be an obtuse triangle. And you're just like, well, this is 146, and this is, well, there's 20 degrees here. That'd be 166, which means there'd actually be room for another angle. So this actually is possible to draw. B could be 146.8, and the way it would look is, instead of being an acute triangle, we would take this side and we would bring it in like this. So you kind of imagine, like, instead of being, this would be a right triangle. Maybe I can try and sketch out like sort of the scenarios. This would be a perfect right triangle, okay? If we draw angle B as acute, it would look like this. That's an acute triangle. And notice, this length is 32 and this length is 20. We could also, though, draw it like this, and this is the tricky ambiguous case. This is still 32, this is still 20, but now this angle is 146.8 degrees. It's the same criteria, but it's the second triangle. There's two ways you can draw this triangle. And if angle B is 33.2, it would look like, maybe I'll draw it in a different color, in a highlighter. This would be one of the triangles in yellow. That's when B is 33.2, or in red, that would be when angle B is obtuse, 146.8. But the way that we know it works is if you add it to 20 degrees, it's still less than 180. So that means it's possible that we could draw two triangles. And then we could solve for side C, but notice there would be two different values because it would be this length or this length. Let's try another one. Let's see what else can happen here. So I'll draw this guy. I'll have A, B, C, just like before. A is 65 degrees, little a is 18, 22, A, B, C. We're going to say the sine of 65 over 18 is the sine of B over 22. Multiply both sides by 22 to get the sine of B by itself. So now I will use the calculator to do 22 times the sine of 65 divided by 18. I get 1.11. No. The sine of B is 1.11 on the unit circle. That's really what we're going with. On the unit circle. On the unit circle, where the hypotenuse of the circle is always 1, the radius of the circle is always 1, so you're telling me that the sine of B is 1.11, even though I know that the biggest sine can be is 1. You want it to be 1.11? I don't think this is going to work. Let's try it on the calculator and just be like, wait a minute. You can't take the inverse sine of something bigger than 1.11. Error. And you're like, well, why would that happen? Why would that be the case? What is happening here is, maybe I'll try and draw it as a right triangle. If I were to draw this as a right triangle, then the sine of 65 would be that x over 22. So if I do 22 times the sine of 65, 22 times the sine of 65, I get 19.94. 19.94. This height is supposed to be 19.94. But if you look right here, you have a triangle where the hypotenuse is shorter than the height of the triangle. So this is not a possible triangle to draw. If this is not at least 19.94, then you cannot draw this triangle. So this is impossible. There is no solution. This triangle does not exist. You can't draw this triangle because this altitude actually needs to be 19.94. So this has to be much longer than 18. It can't be 18. It's got to be at least 19.94 to even form a triangle. So this one's no solution. And I know that because you cannot take the inverse sine of something bigger than 1. Let's try another one. This one says angle A is 20 degrees, so we'll draw a triangle, kind of the same we always do, 20 degrees. Little a is 8, B is 14, and we'll say A, B, C. So we're doing the same thing. And let's see, what's this going to look like? We will do the sine of 20 degrees, again, 20 degrees for some reason, over 8 is the sine of angle B over 14. So to get the sine by itself, we'll multiply both sides by 14, and we'll see what happens. So calculator, 14 times the sine of 20 divided by 8 is 0.599. So the sine of B is 0.599. And I like to try to sketch it and think, is this possible? What am I talking about? Can I draw two different triangles? If the height, this is what we know. The height of this is 0.59. So I will then take the inverse sine of that and get 37 or 36.8. Let's say 36.8 degrees. So this is 36.8 degrees. But this is also 36.8 degrees, and it's possible that instead of talking about this triangle, we actually meant in the second quadrant. So it's this angle, and to find that angle, you would do the supplement 180 minus, and I'm using 36.8, so I'll just keep it rounded, 143.2 or 143.2. Would that fit? If you drill with 143.2 and you have 20 degrees here, 143 plus 20 is still less than 180, which means it could fit. So it could be that this is 36.8 and it's an acute triangle, or it could be that they actually bent this guy in like that, and this is the triangle that we're talking about, and this is 143.2 degrees. So again, you have two different triangles. It could look like this, or it could look like this, but there are two answers that fit this criteria. We still have angle side side, that is true. Angle side side, that would be 8, or that would be 8. But in this case, there's two different triangles you can draw. So this is the ambiguous case. B could fit. You could have 143.2 or 36.8. Couple more. Let's see. I have angle A. Oh, angle A is 155. So here, this one, I'm going to draw it as obtuse, which means I doubt it's possible to fit another triangle in here. But let's see. This is A, B, C, 155. I know that little b is 8.4 and little a is 12.5. So we'll say, using the law of sines, the sine of 155 over 12.5 is the sine of angle B over 8.4. Now we multiply both sides by 8.4. So 8.4 times the sine of 155 divided by 12.5 is, the sine of B is 0.283. So we'll do the inverse sine of that. B is 16.5. Or, if I do 180 minus that, there's no way it's going to fit, because this would be huge. 163.5. Now, if it's 163.5 and you add 155, you get something bigger than 180, which means that wouldn't fit. You wouldn't be able to draw a different triangle. There's just not a way to do it. I think it would have to be like, how would we make A acute? I think it would have to be something like this, but then this wouldn't be 12.5 anymore. So it just doesn't work. And you can't visualize it because it can't be drawn. So the fact that there's not room for this angle means there's not an ambiguous case. The only thing that angle B can be is 16.5 degrees. And that's really because the hypotenuse, well, it's not the hypotenuse, but this length is long. All right, so now let's see if we can sort of summarize this. What's the length where we would end up with two different triangles? So here's the trick. You're basically thinking, when would it be an isosceles triangle? How can you draw an isosceles triangle? So the other way this would look would be like this. So this length is also A. So those are the lengths, and you think, how can I do that? Well, the biggest way that you can get two triangles, or I'm sorry, the cutoff is going to be if it was isosceles. If we drew it like this, and this was 10, and this was 10, then anything longer than that, we saw from our exploration, will be too long to form two triangles, so there's only going to be one triangle. So I know that A has got to be less than 10, because if it's longer than 10, it won't form two triangles. It'll just be like a really obtuse angle B at the top. But I could also figure out what this height would be, and if you know this is 40 degrees, let's figure out what the perfect altitude would be, so what BD would be. I'll say the sine of 40 is my x over 10, so multiply both sides by 10 to get x by itself. 10 times the sine of 40, 6.43. So x is 6. This is 6.43. So if you draw BD as 6.43, that would be a perfect altitude. So it's got to be at least 6.43 to be a triangle. But anything bigger than that, like a little bit bigger than 6.43, like 7, I would be able to draw it two ways. I'd be able to draw it like this and form an obtuse triangle, or like this and then keep my triangle acute. Or I could keep kind of expanding this idea and just getting closer and closer to eventually, when the side A is 10, then you get to the isosceles triangle, and anything bigger than that isn't going to form two. So it's this range where I'll be able to draw two triangles, and it would look like I drew before. If it was a little bit longer than 6.43, like that, you would have the two triangles. But if it gets to 10, and it comes out to here, and it's too long, it'll only form one triangle. So this is the range that would end in two triangles. Last one, what kind of triangle must ABC be? So I think we're going to just find that there's only one way we can draw this. 30 degrees, A is 9, B is 8. We're saying ABC. So the sine of 30 over 9 is the sine of B over 8. And we will then do the same thing we did before. 8 times the sine of 30. 8 times the sine of 30 is 8 times 1/2, which is 4. Divided by 9. It's going to be 0.4 repeating. Let's go. Now we'll do the inverse sine of that. And we get 26.4. So angle B is 26.4 degrees. But what I'm asking now is it possible that instead of going like this, it's actually on the inside and this is an obtuse angle? So to check that, we will do 180 minus that, and we'll see if it's possible. If we had 153 degrees here and we needed to add 30, we would be bigger than 180, which means this wouldn't be possible. So 153 wouldn't be possible to draw because there's already 30 degrees here. So this is the only answer, which means what kind of triangle would be? Well, these only form 50 something, so that means this missing angle has to be what, 123? Oops, something like that, 123.6. So this is actually obtuse. So it must be obtuse. Angle C is 123.6. So triangle ABC must be obtuse because you have an angle bigger than 90 degrees. And we know that because there's only one way you can draw it. It's not an ambiguous case. So this side-side angle stuff is definitely tricky, but the main thing is you take the inverse sine and then you see, could I find two different angles instead of just one? So get your checkpoint done and make sure to hit that like and subscribe.